How's it going, guys? Good to see you all, and I've seen some familiar faces and new names in the chat. So thanks everyone for joining. But before we kick off, going to do a quick sound check. Can everyone hear us? Let's see some.
There we go. Thumbs up. That's what we want to see. Thank you, team.
Getting some thumbs in the chat. Thank you, chat. But yeah, here, look, guys, what we're here to talk about is beyond visual line of sight, advantages of mining. Everyone's talking about is talk of the town, remote operations, BVLOS. We're just going to give you a bit of an idea around it. In particular, what we're going to be looking at is, an intro looking at VLOS, EVLOS, beyond visual line of sight, what kind of capabilities it's going to unlock on a mine site. Some of the key use cases we're seeing. We're also going to have a bit of a deep dive into some remote operations benefits, pathway to democratizing drone automation on site, the current regulatory landscape, upcoming regulatory changes, and the current beyond visual line of sight application timelines and how long those would potentially help. We'll save some time for questions at the end, but by all accounts, as you see stuff, fire the questions into the chat. I know when I'm watching some of these things, I can forget a question once it comes to the Q&A at the end. So just make sure to put the question in the chat, and we'll get around to answering them in due time. But, Jerry just...
Sneak peek for you all.
Yeah, hopefully I didn't ruin my presentation. So really quickly, we're going to do a bit of an introduction. I'll start first as I'm talking. So Cian Gleeson, Head of Strategic Initiatives. Judging by the fact that I don't have chief in my title, I didn't get a white shirt like Elliot, but I manage the commercial element for Sphere Drones, for Drone in a Box implementations, Hub X's, and I do a lot of our project management. So coordinating the team to get people up to scratch around beyond visual line of sight and remote operations. So working with a lot of, I suppose, tier 1, tier 2 mining companies and some civil engineering companies across Australia for these projects. That's my own quick introduction, so I'll pass it over to Elliot.
Nice to meet you all. For those who I haven't met before, nice to see a few friendly names in there. My name's Elliot. I'm the Chief Remote Pilot here at Sphere. So my role within the business is to provide that conduit between the business and the regulator, ensure that we're getting all the correct approvals, make sure that our team are operating safely and effectively, manage all of our operational fleet, etc. But obviously, having been here in the business for quite some time, I provide support to the team when it comes to the technical solutions that we provide as a business, and provide that kind of expertise when it comes to the aviation environment, but then also the solutions themselves, so the hardware, the capabilities, and all that sort of stuff. So enough about me, and on to the presentation.
We'll kick on. Okay, so Sphere Drones, just a little bit of background, guys. Obviously, we've got some new names in the chat, but here, look, we've been tipping around since 2014, started just selling your typical drones, just sending them out to people. Over the last couple of years, we set up our main office out in Alexandria, as well as offices out in Perth as well, with team members across Australia. In the interim, we understood that drones are quite a complex tool that are involved in the mining environment. We set up a hardware engineering team, as well as IoT teams, and then we started focusing on software development. And since then, we've really been looking at systems integrations for drone in a box technology, and the compliance around it. So a lot of people are quite aware that it's not as simple as to take these boxes off the shelves and begin operating. You need a whole host of equipment, from air traffic management systems to environmental sensing to situational awareness. But since then, we've become BVLOS approved. We've IRS accreditation against us, a remote operations center, and we've entered into a partnership with Aptella for some of our systems. But really, what we're here to talk about is more so on the regulation side and the compliance side of things. So I'm going to pass it over to Elliot, who's going to talk about visual line of sight.
Thank you, sir. In terms of our slide that we've got here, basically there are a few different categories that we need to consider when it comes to operations of drones. And so visual line of sight is something that is often a bit of a murky grey area, but effectively the granularity of it is that the terminology of visual line of sight means that the pilot can see and orient the drone with their eyes without the need for any external, devices or, the use of a screen exclusively. So that means that flying behind obstacles, flying over hilltops, flying really long distances is kind of, out of the equation there. If you need to do that sort of thing, you are kind of limited as a rough. It depends a little bit on the type of aircraft, the pilot's skill, experience, the operating environment, etc. But generally, 500 to 750 meters is generally a good rule of thumb for limits of visual line of sight. If you have really good eyes or a really large aircraft or some other capabilities there, then you can potentially increase that a little bit further. But given that extended visual line of sight limitations are that 1500 meter mark, it's very clear that 1500 meters is definitely the limit of BVLOS. When you're doing small scale operations, as you can see, visual line of sight is perfect. It's simple. There's no overbearing requirements there, but it does limit you a little bit in how much of an area you can cover at any given time. So being able to step up to EVLOS allows you to boost that distance to a maximum of 1500 meters from the pilot and the trained observer. You do need to have a trained observer. They don't need to be a remote pilot license holder themselves, but they do have to be trained on the requirements of that trained observer position. And that allows you to boost your maximum distance to maximum of 1500 meters, which means that you can effectively cover a 3-kilometer radius from the pilot and trained observer location. There's two different categories of EVLOS. EVLOS Class 1 means that the pilot and the trained observer have to be co-located, so you're not allowed to use crew communication networks. If you need to be able to cover longer distances, then you can use trained observers that are not co-located with the pilot. So you could use a cellular network or a radio network to communicate, and you could have someone positioned and kind of daisy chain them and cover really long distances that way. But it does, of course, come with more complexity, and so that does require permissions for both EVLOS Class 1 or EVLOS Class 2. As you can see, they are an excellent stopgap from a BVLOS, between VLOS and a BVLOS approval. And the big benefit really with EVLOS is that it's not area specific. So one of the slides we'll talk to later kind of touches on the fact that BVLOS applications are generally area specific. So it is something where you would assess the air and ground risk. Getting ahead of myself a little bit here, I know. But one of the big benefits with BVLOS is that you don't have to use trained observers. So that simplifies operations a little bit in some ways, but it obviously adds complexity in other ways. So part of the requirement there for that BVLOS piece means that you do need to have good situational awareness of the environment that you're going to be operating the drones in. So having things like sensors, cameras, automations, etc., to help you have that situational awareness suite is all really important. So, and the key thing is you can cover really large distances, with that BVLOS application. So, Kian, anything to add there?
You could almost say it unlocks the full potential at a mine site.
It definitely unlocks the full potential at a mine site. That's a good title. That's a good, yeah.
Not bad, marketing team.
Yeah, well done.
But moving on, guys. So, how Beyond Visual Line of Sight unlocks new capabilities in mining sites or mining environments. So, typically a lot of operations at the moment is in VLOS. You're not allowed to fly that drone behind a smokestack, reclaimer, a hill, a mountain. This allows you kind of overcome that limitation, fly wherever you need to fly to collect that data remotely. It'll also enable for larger scales, remote operations, instead of having people travel long distances on sites, you could potentially, fly VTOLs, hybrid drones, drone roboxes, far beyond typical visual line of sight and collect more data a lot more effectively. It also enables, I suppose, better quality work for some of your workers instead of traveling to remote locations. But when we're looking at the key beyond visual line side BVLOS use cases in mining, what we're really looking at is drill and blast observations. So no secret, most mine sites have a requirement to film uh, drill and blast at sites. It's quite questionable. There's a minimum distance required to be away from the blast, and then towards that 500 to 800 meters, can you really see that drone on site? So by having, beyond visual line of sight approval, that'll allow you to effectively cover those blasts. Another one is, mining environments in Australia are quite big, not as big as Ireland, but for these kind of large pits, large scale pit surveys, it gives you that peace of mind to actually effectively cover the area without having to relocate each time that you do a survey. Another one that we see is around infrastructure inspections for some of the fixed plant that are on site. Every time that you do an inspection, you have to follow the drone around the building or the fixed plant. You wouldn't have to necessarily do that anymore. So essentially it allows just for an increase of efficiency on the mining sites. But really where we see it coming into play is anywhere that requires remote data acquisition beyond visual line of sight operations are definitely going to benefit you.
Well said.
Thank you, Elliot. So when we're looking at the next step into it, so beyond visual line of sight, Elliot said is site-specific approval. You got to be at that site to actually operate. The next upgrade to that would be, your remote operation, removing someone from that location completely, and then having a drone in a box on site. Or a different system, typically drone in boxes. And the benefits of this is, we're taking people out of those kind of hazardous areas. When you're down the pit, there's a lot of heavy machinery, trucks that are rolling around constantly. Instead of having light vehicles going in and out consistently, you can automate the data capture remotely from Perth, Brisbane, Sydney, wherever it could be, or even just the dongers on site. It also enables for further CASA compliance. A lot of operations could be doing it already, but just takes it off from a CASA perspective. It's no secret that there's shortages of surveyors out there, so it kind of enables you to attract and retain surveyors as well. In the idea that it could be a little bit more attractive to operate from a nice air-conditioned room with some coffee on site. As well, which is beneficial.
And I think another important aspect of that as well is that you're freeing up the precious resource that can be that surveyor's time. If they're able to focus on the higher priority tasks, then the lower priority tasks can be done by that other team or other location.
Like processing data you're on about there. Yeah, exactly. Perfect. Well, when we're looking at it then, guys, the biggest thing around remote operations and what it really enables you to do is to democratize drone data across the site. So, again, we're talking about a couple of industry secrets here. It's no secrets that surveyors love, drones from a survey perspective. Typically what happens is that the surveyors hold the REPLs on site. And then what can happen then after that is that all the other teams would come to them to do their drone operations, which can lead to capacity issues in that kind of survey team. From remote, when you enable that kind of remote operations team to potentially do some of the work, you're able to build out a schedule of operations, which can really appeal to a lot of different, let's say, teams on site, all the way from survey, fixed plant inspections, the drill and blast teams, the heritage teams, rehab, and then haul road monitoring. So you're able to build out a big schedule of operations that appeals to everyone, give everyone access to the drones on site through this remote operations team. So when we're talking about it, like for example, here's some of the scheduled operations that you could do. A couple of, weekly frequency jobs, and then once monthly jobs. You could be looking at wall checks, blast area preparations, high wall mapping, mine surveys, environmental rehabilitation, And then a big one that we're actually seeing catch on is milestone streaming for construction. So if you're constructing mine sites up in a word that I learned recently from Australian slang is whoop whoop, is that you can actually stream that from to the rest of the company. And it's good for morale just to actually see what's happening up there from the corporate side of things.
Yeah, definitely. I think as well, like one of the key things with this is the democratization, like you say, of providing access to all of these different sources of data from the one system, can be really helpful. And then providing, like opening up that can of worms isn't the right analogy, but opening up that buffet to everyone, rather than having it be something where only a few of the key people have access to it. So it really does enhance the situational awareness of everyone on site.
Yeah, and then it kind of comes down to the frequency of data as well. In, I suppose, past operations, we've seen people just collect data, once a quarter, once a month. By having, I suppose, remote operations there, you can really increase that data, which leads to better modeling, better forecasting as well. So the downstream effects of that is quite advantageous to mine planning. But when we're looking at it, this is a slide for Elliot. So I'm going to pass it back over to him.
Thank you, friend. So as you can see, one of the first points off the mark there is the remote operating certificate. So it is a requirement at this stage that anyone who wants to apply for a BVLOS approval does require to go and get a remote operating certificate, and any pilots involved with the BVLOS operation from actual execution and flying will need to have a remote pilot license as well. There is also a requirement that if you're operating under BVLOS conditions, you do need to have, someone has to have an instrument rating exam theory pass, which is an aviation exam, or an outside controlled airspace OCTA exam that CASA brought in the last little while to basically make the pathway a little bit easier. But it is a requirement that at least one person has to have that. There's a little bit of subjectivity to it. If you're doing the traditional BVLOS, where you've got a pilot out in the field and they're flying outside line of sight from where they are, then that pilot has to have an OCTA or IREX. But if it's something where you're operating in a remote operations center environment where you might have a number of workstations, you can have a supervisory, remote pilot with an instrument rating exam pass or an OCTA supervising a number of pilots who don't necessarily have to have that OCTA IREX exam pass. But it is important to be aware that there is, a requirement there. And then as part of the site-by-site basis, I mentioned before that it is, with BVLOS approvals, they are generally site-specific. It is something where you need to get an approval for an area or a grouping of areas, and then the air and the ground risk needs to be assessed in combination with your concept of operations, basically talking about what you're going to do, how you're going to do it, etc., to ensure that you have a safe operation planned. So there are regulatory approvals for specific concept of operations that have been provided so far. It is something where it is on a case-by-case basis at this stage. As you can see, that they are currently tightly regulated to ensure safety. There are lots of conversations happening at the moment within the industry and with the regulator around how we can make this pathway easier for BVLOS operations to get conducted. But at the moment, it is something where you're not able to operate under the excluded category, which is a relatively common question. And yeah, as you can see, you have to demonstrate that your procedures are robust, safe. You've considered all the different aspects that come into it. And then, in future, hopefully what we'll see is, things opening up a little bit more to enable, some element of self-assessment, but I think that's probably going to be a little bit of a way down the road.
Thank you, Elliot. So you're saying BVLOS approvals are tied to REOC, and that location is site-specific?
That's correct. Yeah. So if you have so under your REOC, you might have an approval for a given area. It doesn't have to be one specific site. So for example, if you have a mining area that has a number of different sites within that specific geographic region. The air risk might be similar and the ground risks might be similar, so they might be able to be considered under one application. If it's something where you have one on one side of the country and one on the other side of the country, it might be something where it's a little bit more complex and you do have to have them considered as separate approvals, but there's a bit of nuance to it.
Thank you, Elliot. Very good.
So I kind of touched on this one a little bit on the previous slide. I kind of got ahead of myself a little bit, but effectively there have been some recent changes which allow for streamlined approvals when it comes to some standard scenarios. So if you have any questions about that, flick us through an email and we're happy to have a bit more of a conversation about it. But effectively, there are some standard scenarios where if your air risk and your ground risk are within a certain set of parameters, then you can get your approval processed more quickly once it gets to the front of the queue. I do believe that if it is that it is subject to the similar sort of wait times in terms of the queue, which we'll touch on later. There has been an introduction in the last little while as well of a temporary management instrument which allows the ground risk classification to be considered under the newer SORA 2.5 calculations. So for those of you who aren't familiar with SORA, SORA is a risk assessment methodology which is accepted and generated by the international aviation community and applied to drones. SORA 2.0 is kind of the current standard and SORA in Australia anyway, and SORA 2.5 is going to be introduced in time, but at the moment they've just kind of brought that ground risk classification functionality in to enable it to be a little bit more streamlined in Australia. The ground risk that we tend to have in Australia, being such a big country, is a little bit different to some of the international community.
Couple of kangaroos around the place.
That's it. Those kangaroos are dangerous. So yeah, we have to. Yeah, that's been a nice introduction. And then yeah, as I said previously, the introduction of electronic conspicuity. So like with crewed aircraft, the more and more crewed aircraft that are carrying and using transponders, the more that happens, the better it will be for uncrewed aviation operators. From a situational awareness perspective, if you've got a crewed aircraft flying through the operational area where you're flying a drone, having them be popping up on your radar system allows you to have that awareness and make that informed decision around whether you need to land the drone or get out of their way, and just improve safety generally. And further to that, the introduction of a UAS traffic management system in future will also improve safety for both crewed aviation and uncrewed aviation. And then CASA, of course, is doing a great job of bringing us forward and bringing BVLOS drone operations into our ecosystem here, and making sure that we're not falling behind our peers in the USA and Europe. BVLOS drone in a box operations are here, and they're not going anywhere. So it's good to see that they're trying to make some changes to keep up with the industry.
Good stuff. And here, look, what we're going to really talk about now is current BVLOS application timelines from what we've seen, really. We've been working on the ground quite extensively with some of our customers, doing our own approvals already. And what we've seen is that, to do your initial application, it can take anywhere for a month once you're working with someone who knows what they're doing, or potentially even longer if you're doing it yourself for your first time. From here, you're going to really sit in a queue from about 6 to 8 months. There's going to be a review process. This typically does take about 2 months, if not longer sometimes. And then you have time for amendments, and then you'd have to book in your on-site CASA inspector. The key thing to note here is this is around BVLOS, and then for a remote operation, you'd have to get amendments for your remote operation center, and then the approval for that, and how I suppose you manage your air traffic, environmental sensors, and then your situational awareness. So it is a bit of a journey for that initial application. I can say that it does get easier after that. There is a light at the end of the tunnel. Your subsequent BVLOS applications post this one, generally it's just taking a month to build out your SORA analysis on that region. And then about 6 to 8 months in the queue, everyone's got to do the queue. And then another around a month then for review and some amendments. So that's typically what we've been seeing. Would love to hear if other people have been experiencing anything different in the chat. Always willing to talk to other people in the industry.
Yeah, I think as well, like that's part of the journey, I suppose, is also understanding what the requirements are for your particular site and whether you have. So I guess there's two aspects there. One is how complex the operation is in on your site, what the operating environment's like, whether you've got a very busy area with lots of people, or whether you have a scarcely populated environment, or whether you have busy air traffic. If you're close to a major city, then that can change the air risk profile, and so of course that can change the amount of time that an application takes as well. So if you've got a particularly complex environment, then it can drag that time out a little bit more. And the other thing to keep in mind is if it's something where it is pressing to get drone operations expedited to cover more area more quickly, it is possible that you can consider those BVLOS applications, where you do have a trained observer out in the field, and you have a pilot in the remote operations center doing those BVLOS operations. So that can be a pathway if it's something where you want to get up and running more quickly and then transition across into that BVLOS environment after that.
Nice one. Thank you, Elliot. And then I suppose we're going to have a quick look at, selfless plug, how we can help. So here, look, we've been doing it over the last while. Beyond digital line of sight, remote operations, we can really help bring your program to that next level when it comes to it by helping you with applying for approvals, or getting you set up and running with a remote operations center. We also offer end-to-end solutions, so around our HubX ecosystems and HubTs. More on that, we can talk about that in a little bit more. I see that someone asked a question around what kind of technology is required to do a remote operation. So I'll get Elliot to answer that in a little second. We also provide managed service from project management implementations to planning on how you get from X to Y, technology associated with it. And then we also have our own operating remote operation center as well, in case there was any interest in us doing the operations on your behalf and sending you back the data.
Yeah, and we've had a few questions coming throughout the webinar, but I guess in terms of our session today, if it is something where any of this has triggered questions for you, off the back of the session, feel free to reach out. We're more than happy to have a conversation with you about how we might be able to support you in ways that aren't listed on the page. So we have had a couple of questions come through. So one question, we had a good question come from Shelley. So in terms of the content of what we showed today has primarily been focusing on the external above ground operations. If it is something where you're looking to conduct drone operations underground, then it is something where it is a good idea to go and get a BVLOS approval to conduct those drone operations safely underground and in compliance with legislation underground. What we found is that often the mining legislation is quite comprehensive and potentially more stringent than the aviation legislation, particularly in that underground environment. I guess the consideration with regards to BVLOS in underground environments, technically it's still a drone, even though it's not in airspace. So there is a bit of area for interpretation there. But from our previous experience, what we've actually done is we've gone and got a BVLOS approval for enclosed spaces. So it's a separate BVLOS approval to the traditional BVLOS approvals. And yeah, if you want to have a chat with us about that, please feel free to reach out. We've got one here from Darcy around the introduction of FIMS, etc. So look, I think any introduction of a more comprehensive situational awareness suite by the aviation community at large will certainly see expedition of BVLOS approvals and allow the regulator to have more confidence in granting those approvals. in terms of the specific question that Darcy asked, sorry, I just realized that not everyone can see the question. The question was, what is the likelihood of speeding up the BVLOS application process with technology like FIMS or electronic approvals similar to the trial done around airports like Sydney, etc.? So, look, I expect that'll be something that'll come in time, but I think that it's still relatively early in the piece for truly automated applications. But never say never. I think it'll be something where once people do demonstrate to CASA that operations can be done safely and effectively, and that situational awareness piece is there from the aircraft side as well. It's important that at this stage, drones, the regulators don't want uncrewed systems to be carrying transponders unless they are specifically playing in airspace that requires it or warrants it. So the likes of your Scan Eagles, etc., operating up in very high altitudes around crewed aircraft, that's where you might see transponders being used. But at the moment, that technology is not necessarily being utilized. So, long story short, if once that technology suite comes in from the community and the regulator, etc., it might be something where we see that expedited.
Yeah, no worries. And then we also have a question from Chris there, just on the technology required to do a remote operation. Typically, it's broken, and CASA loves redundancy around it. So when we're obviously not in that environment, we're required to understand what's actually happening in that environment from an environmental perspective, situational perspective, and then your air traffic management. So just having weather sensors out there, cameras, as well as capability to monitor local air traffic, and then most importantly, speak to that local air traffic. So your radio over IP functionality, and then it's also looking at connectivity solutions to be able to power that. So when we're talking about redundancy, potentially bonded center modems, Starlink, operating from a combination of LTE and SAT connectivity, is always good to prove to the regulator that you're able to have those kind of redundant operations.
Yeah, for sure. Yeah, and having a person in the remote operations center, you really want them to have the best situational awareness that you can give them. If given that you don't have a trained observer on site, you don't necessarily have to have a person on the ground there. It is important that you have the best information that you can, so you can make the most informed and safest decisions when it comes to flying a drone. I think one thing that people often overlook is the fact that drones are technically an aviation activity, and they are, of course, playing in airspace with crewed aircraft traffic. So you need to ensure that things are done in the safest way possible. So, yeah.
I also like the fact that someone asked a question there saying Q for Elliot as opposed to Cian. I'm not going to take insult to that one, but I know who you are.
Yeah, very discriminatory. I love it. It's not because you're Irish.
I hope not.
Cool.
All right, guys. Well, if there's any further questions, it'd be good to field them. I think my details are on the next slide there. So feel free to drop either me or Elliot. It sounds like more Elliot questions after the meeting. We can definitely catch up anyway. And if anyone has any plans or just further clarifications, please reach out.
Thanks so much for your time, everyone.
Thank you, guys. Pleasure speaking to you all and having your engagement with your thumbs up. All right. See you later, guys. We're going to log off. Bye-bye.